Now that we've reviewed the Pythagorean Theorem, which I know you guys have seen in other years of math, we're going to move on to more special rules related to right triangles. So of course you know the Pythagorean Theorem works with right triangles, but there's also some other characteristics of right triangles, and so we'll take a look at that here through a little investigation. The investigation says, use the Pythagorean theorem to solve for the missing side of the right triangles below. Express your answers in simplest radical form. So last time we looked at how to change a number into simplest radical form, and we'll need that here to notice the pattern. So let's start off with Pythagorean theorem on the first triangle here. So this is an isosceles triangle, and not only that, it's an isosceles right triangle. An isosceles triangle that is a right triangle has angles of 90 degrees and then 45 and 45. So these are also known as 45, 45, 45 degree, 45 degree, 90 triangles. All isosceles right triangles will have those degree measures. So in all these we've got 45, 45, and 90. Every single one of these, 45, 45, 90, 45, 45, and 90. Okay, so now that we have established what we're looking at here, let's take a look at the pattern. So a squared plus b squared equals c squared. Let's do that here. 1 squared plus 1 squared is equal to c squared. 1 plus 1 is equal to c. So, sorry, c squared. So 2 is equal to c squared. And remember, to solve for c, we need to take the square root of both sides. So c is actually the square root of 2. All right, so that's the length of c. Square root of 2 units. Maybe it would be good to put that there since it is a length. All right, let's check it out with the second one here. We have 2 squared plus 2 squared is equal to, again, let's call that c, so c squared. So that'd be 4 plus 4 is equal to c squared. 8 is equal to c squared. So c is the square root of 8. So a square root both sides. C is the square root of 8. But what I want to do with this is just put it in the simplest radical form. So remember how to do that. We look at what perfect square is a factor of 8. And the biggest perfect square that's a factor of 8 is 4. So let's separate that out into 4 times 2, because that's equal to 8, which means that we have the square root of 4 times the square root of 2, and the square root of 4 is 2. So 2 times the square root of 2 is what c is equal to here. Again, think back to what we did. Simplest radical form is basically just changing the square root of 8 into what we call simplest radical form, which involves some steps, which I won't go through here because that's not the lesson again, but I did go through the steps of how to get it. What we're saying is 2 times the square root of 2 is the same thing as the square root of 8. So if you punch those in on your calculator, you'll get the same decimal answer here as you did down below with the 2 times the square root of 2. All right, so the next one, we have 3 squared plus 3 squared is equal to c squared. So that would be 9 plus 9 is equal to c squared. 18 is equal to c squared. And therefore, c is the square root of 18. In simplest radical form, we'd say, okay, what's the biggest perfect square that is a factor of 18? And that would be 9. 9 times 2. So the square root of 9 times the square root of 2, which is 3 times the square root of 2. Because the square root of 9 is 3. So the length of c is equal to 3 times the square root of 2, which again is the same answer as the square root of 18, but it's in simplest radical form. And finally, this one, maybe you're already noticing the pattern, but 4 squared plus 4 squared is equal to c squared. 16 plus 16 is equal to c squared. That would be 32 is equal to c squared. C is the square root of 32. In simplest radical form, that would be the square root of 16 times the square root of 2, or 4 square root of 2 is simplest radical form of the square root of 32. Do you see the patterns here? What are you noticing about the length of a leg and how it appears in the final answer for the hypotenuse? So back in 1, we've got c is the square root of 2. So maybe 1 square root 2. C is 2 square root 2. Notice the leg is 2. And the next one, C is 3 square root 2. Notice the leg here was 3. And the next one, C is 4 times the square root of 2. Notice that the leg here is 4. So every single one of them involves square root 2 at the end when it's in simplest radical form. And every one of them, it's the length of the leg that goes in front of the square root 2. This is always going to be true. And it's called the 45-degree 90 rule, or the isosceles right triangle conjecture. It says in an isosceles right triangle, if the legs have length x, then the hypotenuse has whatever that length is, so x times the square root of 2. So if we make a sketch of a 45, 90 triangle here, so 45 degrees, and 90. If we call the legs x, then the hypotenuse will always be x times the square root of 2. All right, so find the missing legs down here. Well, you know that the hypotenuse is x times the square root of 2, and we know that the two legs are the same length, and remember those were x, so x equals 25 and x equals 25. So what is the length of the hypotenuse? Well, x times the square root of 2. If x is 25, then that length is 25 times the square root of 2 units. Okay, so that's it. We didn't have to do the Pythagorean theorem here, notice, to get the hypotenuse. If we notice that this is a 45, 90 triangle, we can use the length of a leg to get the length of the hypotenuse. Okay, what if we worked our way backwards here? We know that this is x times the square root of 2 for the hypotenuse, and each one of the legs is x. So what is x? Well, x is right here. X is 13, because that's the number in front of the square root of 2. Now, you could also think of it this way. You know the hypotenuse is equal to x times the square root of 2. So we can almost think of it as a formula. Well, 13 times the square root of 2 is the hypotenuse. So that equals x times the square root of 2. Do a little bit of algebra here. Solving for x, divide both sides by the square root of 2. And notice that we get, cancels out, 13 is equal to x. So it's almost like we could do our steps of our formula right here that we've been doing in the last few units. Step 1, step 2, plug in the numbers. Step 3, do the algebra. Step 4, state the final answer. Maybe put some units on there if there aren't any units. And there we go. So that would be another application. Another example down here. All right, this one notice says find the area. Find the area of the right triangle below. Okay, well we know this right here is an isosceles right triangle, which means that's 45, and 90, so we can use our rule. We're given the hypotenuse is 12 feet, but we have to get the area, which means we're going to have to work our way backwards here. We're going to have to figure out what the base and the height are to be able to get the area, because base times height divided by 2 is our area. Okay, so let's start off with the fact that we have the hypotenuse, which we know is equal to x times the square root of 2. So in this one we know the hypotenuse is 12, so 12 is equal to x times the square root of 2. Now let's do our algebra to get x by itself. The hard part of this one is that the hypotenuse is not expressed as something square root 2. So this you really do need to do a little bit of algebra with to solve for it, because it still has the relationship even if you don't see the square root of 2 there. So do a little bit of algebra, we find out that x is equal to 12 divided by the square root of 2. And I'm not going to change that to a decimal right now. I'm just going to keep it with the square root of 2. So now we know that the base and the height are 12 over square root 2. 12 over square root 2. Okay, now let's go ahead and do our area. So area is equal to base times height divided by 2. So we've got base of 12 over square root 2. The height is 12 over square root 2. And it's all over 2. All right, we have some fractions here. Don't get freaked out. We'll get through it together. All right, let's multiply those fractions on top there. Multiply across the numerators. So 12 times 12 is 144. Square root 2 times square root 2, so multiply the denominators. Square root 2 times square root 2 is the square root of 4, which actually works out to just plain old 2. When you square a square root, it's kind of like it gets rid of the square root. You just get 2. So square root of 2 times square root of 2 is square root of 4, which is just 2. But we still have the 2 in the denominator. Okay, so now let's still do the numerator here. 144 divided by 2, all right, is 72. So we have 72 divided by 2. And what is 72 divided by 2? That is 36. So our area we worked out is 36 square feet. I'm sure glad that I did not take a decimal for the 12 divided by square root 2 because the answer is exactly 36. And if I had rounded it back here to its decimal, I would have gotten an answer here close to 36, but probably not exactly 36. And in fact, the area is exactly 36 square feet.